Okay, so as we read from left to right, the powers of x are decreasing by 1 each time, right? So we start out with x to the fourth, which is what n is, and then x goes down a power to each term until it gets to x to the 0, okay? Now, the powers of a are increasing by 1. So we start with 0, and then we have a to the first, a to the second, a cubed, a to the fourth. And again, a is almost always going to be a constant. It's going to be a number, okay? So, and we'll do some examples in just a second. But if a were like 4, okay, then the first term, well, okay, let's make a 3, and we were on that last one, and n equals 4. So the first one would just be x to the fourth. The second one would be 4 times 3 times x cubed. Then it would be 6 times, yeah, 4 squared, or 3 squared, sorry. Because we said a was 3, right? So 6 times 3 squared times x squared. Then it would be 4 times 3 cubed times x, and then it would be 3 to the fourth. Okay, that's what your expansion would look like there, okay? So now, notice that the number of terms is equal to n plus 1. In other words, when it's n equals 2, I have 3 terms. When n equals 3, I have 4 terms. When n equals 4, I have 5 terms, okay? And the last thing, the degree of each monomial is equal to n. So if you look at n equals 3, okay, all those degrees, the degrees of each monomial is 3. They all goes up to 3. If you look at n equals 4, each one of those terms, okay, the degree adds up to be 4. All right, so that's kind of setting our pattern here.
What does that mean, the degree of
Each monomial, okay, that means, for example, okay, so let's look at n equals 4 here, Larissa. So if I look at this right here, the degree of that is 4, correct? Okay, if I look here, I've got a to the first, an x cubed, 1 plus 3 is 4. I have a squared x squared, that degree is 4. A cubed x, that's 4. The degree is 4. So the degree is always equal to n. So that'll kind of help you to keep your power straight. Okay? So we're pretty good on, hopefully, on the exponents now, but now we got to figure out how to come up with the coefficients. And what are the coefficients? They're just the numbers in front of each term. Okay, in order to do this, we've got to introduce a new symbol for you, and it's what is called n choose j, or n taken j at a time. Okay, and that's that symbol right there, this thing right here. Okay, so it's a parenthesis with an n over a j. Okay, and it simply means the following. Okay, so n over j is n factorial over j factorial times n minus j factorial. Okay. So again, and that means factorial. And what does factorial mean? We've talked about it. So if I had 4 factorial, what does that mean? What's 4 factorial? 4 times 3 times 2 times 1. Okay, what is 3 factorial? 3 times 2 times 1. What's 5 factorial? 5 times 4 times 3 times 2 times 1. Okay, good. All right. So now, which means we multiply all the integers in this case, okay, now if I have n factorial, I go from n to all the way down to 1. Okay, so let's practice a little bit. All right, so we want to evaluate 3, choose 1. So this means, so n is 3 and j is 1. So I go 3 factorial over 1 factorial times 3 minus 1 factorial. What's 3 minus 1? 2, right? So I have 3 factorial over 1 factorial times 2 factorial. Okay, well, what's 3 factorial? Yeah, 3 times 2 times 1 is 6. What's 1 factorial? It's 2. Yeah, we're not getting crazy here, Larissa. We're not going E. Okay, so 1 factorial is 1. What's 2 factorial? 2. So 6 over 2 is 3. And you're going to find that's true. If I have some number n here and 1 is my second one, that always equals n. Okay. All right, so now let's do 4 choose 2. So now we have 4 factorial over 2 factorial times 2 minus 2, or 4 minus 2, or 2 factorial. So what is 4 factorial? Yeah, 4 times 3 is 12, times 2 is 24, times 1 is 24. So that is 24 over, what's 2 factorial? 2, and 2 times 2 is 4, so we wind up with 6. Okay. All right, now we have 8 choose 7. So this gives us 8 factorial over 7 factorial times 1 factorial. And do we really need to write 1 factorial? No, because this is 1, right? Okay, but now, instead of multiplying out 8 factorial and 7 factorial, let me show you a slick way to do this, okay? I'm going to rewrite 8 factorial so it looks like this. Because what is 8 factorial? It's 8 times 7 times 6 times 5 all the way down to 1, right? I'm going to write it like this. I'm going to write it as 8 times 7 factorial. Right? Now, if that's over 7 factorial, now what can I do? I can cancel my 7 factorials, and what's left? Just 8. Okay? Yes, that's one great thing about factorials. Instead of getting gargantuan numbers here, okay, you can just write one in a certain way so it cancels out with the other one. And you can do that top or bottom. Okay? All right, so let's try some here. All right, so all of this stuff leads us up to the binomial theorem. Binomial theorem, which is a much easier way to expand binomials as opposed to multiplying them out by hand. Ugh. All right, so now we're going to let x and a be real numbers. For any positive integer n, we have x plus a to the nth equals, okay, remember our summation. So we go from 0 to n of n choose j, and then this is just a formal definition for what we figured out before. So x to the n minus j, so x starts at n and then goes down 1 each term, and then a goes up 1 each term. Okay, its degree goes up 1, and we'll show you that. But this n choose j, that's how we find our coefficients. Okay, so clear as can be, right? All right, maybe not. Let's work out a couple problems, and hopefully you can start seeing the patterns. Okay. So the first example now, so we're going to use a binomial theorem to expand x plus 2 to the 5th power. So in this case, again, a is 2 and n is 5. Okay? So here's how it works. So we go 5 choose 0, remember n over j, and then we have x to the 5th power, or x to the 5 minus 0, n minus j. Okay, and then we're going to add to that 5 choose 1, okay? And then times 2, because that's a, that's this one right here, 2x to the 4th. And then it's 5 choose 2, and then 2 squared times x cubed. And then 5 choose 3, 2 cubed times x squared. 5 choose 4, and times 2 to the 4th times x, and then 5 choose 5 times 2 to the 5th. Okay? I know, it's all crazy. Let's start. I know, it's okay. Let's start working it out. Okay? So the first thing we want to do is let's simplify our first term right here. So 5 choose 0. So that means I have 5 factorial over 0 factorial times 5 factorial. Okay? Now we need to give a special definition here. 0 factorial equals 1. Okay? Yeah, so what's 5 factorial? So if 0 factorial is 1, I don't even have to worry about it. What's 5 factorial over 5 factorial? 1. It's 1, right? Yes. See you later. Have a nice day. So our first term then is x to the 5th. It's 1x to the 5th. We're not going to write that 1 though, okay? All right, now let's figure out our second. Actually, I want to write that down a lot lower. I want to write it down here. So our first term is x to the 5th. Oh my gosh. Okay, so now let's look at our second term here. So we got 5 choose 1. So that's 5 factorial over 1 factorial
Isn't anything over 1?
times 4 factorial.
Isn't anything over 1 n? So it'll just be 5.
Correct. Okay, yeah, we just talked about that, right? If the 1 is here, now, but let's see it, right? So the 1 factorial, don't worry about. 5 factorial over 4 factorial is simply 5, right? It's 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Cancel out your 4 times 3 times 2 times 1, and you're left with 5. Okay, so now we have, so this is now 5 times 2x to the 4th. So that gives us 10x to the 4th. Okay. Now we go to our third term, 5 choose 2. So that's 5 factorial over 2 factorial times, 5 minus 2 or 3 factorial. Okay? All right, so a couple ways we can handle this. You can multiply 5 factorial out, it's not too hard. Or we can do this. We can go 5 times 4 times 3 factorial over 2 factorial, 3 factorial. So now what can I do? Cancel out the 3 factorials. Good. 5 times 4? 20. What's 2 factorial? 2. 20 over 2 is 10. Okay, so 5 choose 2 is 10, and then I'm going to times that by 2 squared. So 2 squared is 4, times 10 is 40. And then I have x to the third. Okay, now let's go 5 choose 3. So I get 5 factorial over 3 factorial times 2 factorial. Didn't I just do that one? That's the same one we just did, right? Okay, sweet. So that is 10. And then I'm going to times this by 2 to the third power. What's 2 to the third power? 8 times 10 is 80. X squared. Okay. All right, now we have 5 choose 4. What's 5 choose 4? 5 factorial over 4 factorial times 1 factorial. We already know what 5 factorial over 4 factorial is, correct? That's going to be 5, right? So this is 5 here. And 5 times 2 to the 4th. What's 2 to the 4th? 16. What's 5 times 16? 80. Good. So you get plus 80x. All right, now what's 5 choose 5 going to give me? It's going to give me 1, right? I have 5 factorial over 5 factorial. So that's 1. Then what's 2 to the 5th?
Wait a second. Oh, yes, because the factorial. Okay, I got it.
Good?
Yeah.
And there's our expansion right there. That's your answer. Yep, that is x plus 2. This right here is x plus 2 to the 5th power. Now you can do it that way, or you can do x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2.
Numbers come from, like, the 2 and 4 and 2.
Okay. All right, they came from, all right, let me go back to the other page, Larissa, hang on a second. Well, okay, well, let me show you on the equation here, okay? They came from, let's try this. Okay, they came from this stuff right here. Okay? Particularly from this A to the J. Because in this case, A is 2. Okay? So if A is 2, all right, then I have A to the J power. So we always start with, this is where J is 0. This is where J is 1. This one J is 2. J is 3. J is 4. And J is 5. That's how J goes. Okay? So if A, then for each term I have A to the J power. So in this first term I have 2 to the 0 power, which is just 1. okay, in this first term here. Okay? So in this term, I have 2 to the 0 power, so that's why I don't have a 2 there. This term, I have 2 to the first, or j to the first. 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth.
Where did the other numbers come from?
Which other numbers?
X to the fifth, 2x to the fourth.
Okay, that's this right here. Okay, x to the n minus j. Okay, so we know n is 5, right? So in here j was 0, so 5 minus 0 is 5. Here j is 1, 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. 5 minus 4 is 1. Or 5 minus 1 is 4, sorry, and then 5 minus 5 goes away. Okay, so again, first term, okay, the x always starts with the biggest power with n and then goes down 1 every single term. The other one, this number right here, starts with 0, 2 to the 0 power, and then it goes up 1 power every single time. Okay? So the first term starts at n and goes down a power. The second one starts at 0 and goes up a power for each consecutive term. And then we do the n choose j to get the numbers out in front. Okay?
Okay.
Let's try another one, shall we?
Are we gonna have to write all that out on the test?
Well, I will need, if I give you something like that, like x plus 2 to the fifth, I'm going to need this answer right here. Okay? I would show some work, because then I can give you partial credit, right? All right, yeah, or you can just do it all by hand, which would be really stupid. But anyway. Okay.
Well, you could for sure do
I don't know about for sure. Think about the adding, subtracting you got to do. I guarantee you're going to make a mistake. I had a couple students try it last semester. It didn't turn out well. I'll just tell you right now.
Have another test, it's like they were like all over it.
Yeah. Okay, so now here, all right, so now in this case, n is 4, x is equal to 2y, and a is equal to negative 3. Okay, because it's a minus inside now, all right? So let's use our expansion, okay? So our first one then is, now n is 4, so we've got 4 and 0, okay? And then we're going to have x to the fifth power. What is x? 2y. So we're going to have 2y to the fifth power. Okay? Plus. Now our next one is,
Okay, wait, how did you get 2y?
because that's that's right there. That's x. That's our x.
Oh, we're not gonna x.
Oh, I said fifth. Sorry, I'm thinking of the last one. It's 2y to the fourth. Sorry, my bad. 2y to the fourth. Yeah, because you gotta jump that 2 up as well. Okay? So now our next one then is 4 choose 1. Good. Of 2y to the third power and negative 3 to the first power. Good. Okay. Next one. 4 choose 2 of 2y to the other way, 2y to the second power. I did third on the other one, and then negative 3 to the second power. Good. Then we have 4 choose 3 times 2y to the other way, first, and then times negative 3 to the third. Good. I ran out of room. Okay. And then our last one, hang on, let me see if I can scoot this over. And then is 4 choose 4 times 2y's gone, right? It's 2y to the 0, which is gone, and then negative 3 to the fourth power. Okay, let's crank it out. So what's 4 choose 0? Yeah, so if you have a 0 on the bottom, it's always 1. Okay, so 2y to the fourth then. What's 2 to the fourth? 2, 4, 8, 16. So we have our first term is 16y to the fourth. Plus Oh, I gotta write that low, down lower. Doggone it, I did it dumb again. 16y to the fourth, okay? Plus, all right, 4 choose 1, what's that one gonna be? 4, good. Now 2y cubed, what's 2 cubed? 8, so we have 8y cubed and negative times negative 3. So, let's see, 4 times negative 3 is negative 12. Negative 12 times 8? Say negative 96. So I get negative 96, y to the third. Okay? 4 choose 2. So that one we have to write this out. 4 factorial over 2 factorial, 2 factorial. Okay, so what's 4 factorial? That one shouldn't be too bad. 4 times 3 is 12, times 2 is 24, right? So 24 over 4 is 6. So we get 6 times, what's 2y squared? 4y squared. And then negative 3 squared is 9. All right. 6 times 4 is 24. 24 times 9. Somebody help me out. Let's see, 240 minus 24 is 216, right? So we get plus 216 y squared. Okay? All right, 4 choose 3. What's that going to be? Just going to be 4.
I don't understand how you got 8.
How I got what?
On the first one, it's 4 and then 8 y.
Because 2 cubed
Oh.
is 8, right? Do you see that? So I take this 2 and I cube it, and that gives me my 8 there.
Okay.
We
So
good?
you're not, why are you not multiplying the 3 in yet?
I did.
Well, to the 4, like, so it's negative 12.
I did,
It's
dear.
not simplifying all the way?
That's right there.
Oh. Gotcha.
We okay? Sure.
I wasn't looking down.
All right, good girl. Okay, Heather's all right, everybody. We can move on now. Okay, well, now I don't know where crap I, oh, here we go. Okay, so we got 6 times, so what did we decide that was, 216? Again? So we get 216y squared. Oh my gosh. I am so brilliant. I can't even keep up with myself. All right, next one. So oh yeah, okay, here we are. 4 choose 3 is 4. Then I've got 2y, and what's negative 3 cubed? Negative 27. So 4 times 2y is 8y is 8. 8 times 27? Help me out, calculator people. 8 times 27. Should be like 2.
This should be the bonus.
216 again. Oh yeah. Not going to happen. So now this is a minus because of that negative right there. So it's minus 216. Oh my heavens. Correct. Y. Good. Last term. What's 4 choose 4? 1. What's negative 3 to the 4th power? Done. There's our answer right there.
Let's just call that the final. Gosh. Or let's take the final in class.
Yeah. Well, I can do that, then I got to divide all your scores up 100 by all your scores then, all right? So, because everybody gets the same score?
Yeah.
So I'll just take that 100 and divide it up 25 times, everybody gets a 4, and we move on.
That should be the bonus. Well, actually,
Eh.
as long as you try to get it.
No way.